Okay, everybody, so the first thing you're going to want to fill in on your guided notes here are the words that you see on the screen. Corresponding parts of congruent triangles are congruent. And the reason I have boxes around some of those letters is because we're going to sort of abbreviate this phrase by using Cpctc. We don't need it necessarily right now, but when it comes to doing proofs later in this unit, we're going to use the abbreviation Cpctc, and it means corresponding parts of congruent triangles are congruent. So, what does that mean? Here's what that means. If you are given two triangles, and you are given one of these, this is called a congruence statement. This is a congruence statement. That statement is very, very important because, as I've said all along so far this year, you cannot trust the way that a picture looks. There has to be other information that you can rely on. So in this case, when they say triangle XYZ is congruent to triangle WMN, the order matters, and that order tells us what parts are actually congruent. For instance, the fact that angle X is first, or the letter X is first, and letter W is first, that means X and W are the same size. The fact that Y is in the middle and M is in the middle, Y and M are the same size, same shape. Remember, that's what congruent means, same size, same shape. And then Z and N are the same size, same shape. And we know that based on the statement, not based on the picture. Whoops, that eraser was a little bit bigger than I wanted. All right. So that's one thing the congruent statement gives us. It tells us which angles are congruent. That's not all it tells us, though. Okay. It also tells us which sides are congruent. And here's how. The fact that X, Y are the first two letters in that congruent statement, and WM are the first two in that congruent statement, I know that XY and WM are the same length. Then, if you think of YZ and MN, YZ, MN, same size. And then the one that's not as obvious, it's a little tricky, but you have XZ and WN. It's kind of like the first and the third letters. So XZ and WN. The congruent statement tells you which sides and which angles are congruent. If we look at this next example, this picture looks a little differently, but it's still the same idea. Okay? EHG is congruent to KFG. Well, let's do sides first. EH come first, KF comes first. Cool. HG is going to be congruent to FG. See, that's one that if you didn't understand congruent statements, you may think that those two would not be the same. And then the last one is EG is going to be congruent to KG. Okay, now let's talk about angles. Angle E and angle K. E is first, K is first. Angle H and angle F. Angle H, angle F. And then angle G is congruent to itself, which we already knew because G, these are vertical angles, which we know vertical angles are always congruent. All right. Let me go back here. I feel like maybe there was a second part. Yeah, there's a second part down here. I almost missed this part. Okay. Let's talk sides. AB, congruent to CD. BC, congruent to DA. And then AC, congruent to CA. Well, that's just saying that this side is congruent to itself. And I'm going to go ahead and throw this out here for future reference as well. This is called the reflexive property. That means anytime you have a side or an angle that is congruent to itself, that's called the reflexive property. All right, let's go angles. Angle A and angle C. Well, where is angle A? Is angle A here or is angle A here? We don't really know. What you want to keep in mind is that you're dealing with two different triangles here. This is the triangle ABC. So when I'm talking about angle A on that triangle, that needs to be here. And then when I'm talking about over here, angle C on that triangle would be this angle up here. Two different triangles. Angle B and angle D, B and D, and then you have angle C on this triangle congruent to angle A on this triangle. Be careful of those. You should know those as well because of alternate interior, alternate exterior angles. Okay. For this one, I want you to tell me what the congruent statement is. So I know that we're going to have a triangle being congruent to another triangle. Just look at the sides. Sides are probably going to be your best bet. On this triangle, I go from D to W, and then from W to K. So if I call that one DWK, when I go to my second triangle, I need to start in a comparable angle, which would be angle U, right? Those two both have the one angle marking. I want to go through that one notch mark. So that's going to be U to A, and then from A down through my double notch mark to there. Okay, last one here. We don't even have a picture. All I know is that DO and CA are the same. Well, here's DO, but I don't see CA anywhere else. So I can't really use DO for anything because I don't have CA to compare it to. I see OG is the same as AT. Well, here's OG and here is AT. Those I know are the same. Those I can set equal to each other. So there is some information here that I don't need. Okay, I didn't need DO, I didn't need DG. So now this just becomes a quick little two-stepper. I got 2x equaling 6. Divide both sides by 2. And I got x equals 3. Okay, and I may be asked to plug something back in along the way.